So in the last foldable, we talked about what is proportionality mean and what does it mean to have proportional relationships. Now we're going to look at, and another word for proportional relationships is, or proportionality is directly proportionate. And then if it's not proportional, we say indirectly proportional. So we talked about, in order to be proportional, we must have a straight line that goes through the origin when we graph our line. And so when we have proportional equations, now we're going to jump kind of to the equation part. Last time we looked at the graphs. Now we're going to look at the equation in the tables. Now we're going to look at the equation part. Proportional equations are always written in the form of y equals kx, where k is my constant of proportionality, it's a number that we multiply by. We multiply it by x. And we find k by doing y over x, or we divide y divided by x. That is how we find our k value, or our constant of proportionality. And so we've got some examples here where we've got some proportional equations, and we need to find the constant of proportionality in each equation. And so y equals 4x. Well, our constant of proportionality, remember that when we have our equation is set up as y equals kx, 4 is substituted in for k, so my constant of proportionality, or k in this case, is 4. On this next one, again, our equation is y equals k times x. In this case, 1/2 is being multiplied by x, and so k is equal to 1/2. On this last one, we have something times y equals x, and we have to get this 1/3 over to the other side with the x in order to figure out what k is, because it's not ky equals x, it's y equals kx. So the inverse of multiplying by 1/3 is dividing by 1/3. I also know that in order to get rid of fractions, I can always multiply by the reciprocal, because then 3 and 3 cross-reduce to be 1 and 1. And 1 and 1 are already reduced, so that 1 times y is just y. And I know that if I multiply this side by 3, that I have to multiply this side by 3 over 1. And 3 over 1 times x is 3x. So now I have y equals 3x, and the number that's multiplying by x is my k value. In this case, k is equal to 3. So in example 2, we have some equations that are not proportional, and what it says is the equations below do not represent proportional relationships. Why not? We're going to look at this equation first. This first one says y equals 5, 6x minus 8. This one is not proportional because of this minus 8. If we have addition or subtraction after our x term, that means that this line is not going to go through the origin. If we graphed it, 0, 0 would not be a solution. So we cannot have addition or subtraction because it won't go through the origin, or through 0, 0. Again, if you look back up here, it doesn't say y equals kx plus b, or plus another variable. There's no addition or subtraction in our proportional equation. So because of that minus, this is not proportional. On this next one, we've got xy equals 12. Let's try and get y by itself and see if we have a term times x. So in order to get y by itself, I have to use inverse operations. The opposite of multiplying by x is dividing by x. And x divided by x is just 1. 1 times y is y. Y equals 12 over x. This is not proportional because x cannot be in the denominator. When we write our equation and we have y equals, x cannot be in the denominator. It has to be in the numerator. It can be multiplied by a fraction, up here 1/2 times x, where like if we multiply straight across x over 2, that would be fine if it's in the numerator, but it cannot be in the denominator. Same thing for this equation here. Y equals 10 over x. X cannot be in the denominator. If it is not proportional because it does not follow the format of a proportional equation, which is y equals kx.